Hello everyone, my name is Mingda Zhang and I'm very excited to present our work on story completion with explicit modeling of common sense knowledge. This is a joint work with Keren and my advisors, Professor Rebecca Hua and Professor Adriana Kovashka. Modern AI models have achieved impressive performance in many fundamental vision and linguistic tasks. However, we note that they are still having difficulties to deal with reasoning tasks, especially when common sense knowledge is required. In this work, we choose a specific task that is easy for even kids with limited training, but is still very challenging for machines, that is, to predict the ending of a given story. We select this task because choosing the correct ending requires understanding unspoken messages in a given story, and a key component in this process is to capture common sense, which is usually missing from the context. Therefore, it is a good testbed to evaluate the capability for current machines to perform common sense reasoning. Also, the progress on this task may transfer to other applications that require common sense understanding. Several prior work has attempted to tackle this challenge from different perspectives, such as linguistic features, generative pre-training, and emotion evolution. We explored the possibility of solving the task with more careful curations with structured common sense knowledge. This is the overview of our proposed model. We first train a common sense relation classifier on a structured common sense knowledge base, then transform the story context and ending into a three-dimensional tensor capturing pairwise relations, which is later aggregated to obtain a scalar score indicating compatibility. Specifically, we used bidirectional LSTM to encode arbitrary phrases into fixed-length vector, then with a bilinear interaction module, the scores for different relations can be obtained. We choose ConceptNet as the structured common sense knowledge database. On most of relation categories, we get over 90% accuracy. Since some categories have very few examples and the performance is unreliable, we only preserve the relations with high accuracy. Our model achieved slightly better performance on a public benchmark. Later, the relation classifier will be frozen and used as an off-the-shelf tool. Next, we discuss how to aggregate the relationship tensor for a scalar score. We used a similar idea with squeeze and excitation to dynamically adjust the weights over different relations based on different inputs, and then applying attention on specific tokens within contexts and endings. A scalar is finally obtained as compatibility for each story ending pair using weighted summation, and the ending with higher score will be selected as final prediction. We also build a bi-LSTM module to capture the coherence, because the previously described module doesn't preserve the narrative information. To avoid interference from external data, our coherency module is only trained on the story dataset from scratch. We validated our approach by comparing with a few baselines for querying the external knowledge base. For example, direct syntax matching aims at searching within the knowledge base, but may suffer from high missing rate. We also measured cosine distance of paired entities, which ignores the specific relation but only produces a similarity score. Our proposed approach outperforms all the baselines. Also, our common sense branch can boost the performance of the bi-LSTM language model, implying the importance of using external knowledge to help understanding hidden message. We also found that our common sense branch slightly outperforms the alternative method in prior work. However, for the full model, since we used a language model without pre-training, the results are not directly comparable. Our final model achieves comparable results to several prior methods without using pre-training but additional features. We also noticed that there still exists room for improvement in our current model setting. For example, the dataset for training is of limited size and may not fully support training complex models. The relation classifier may need fine-tuning or recalibration before applying to the downstream task. Also, instead of fusing two parallel prediction branches in the end, the narrative coherence and common sense knowledge could be better integrated in a more holistic way. In the future, we plan to further revise our model by incorporating pre-trained language models as an additional source of implicit common sense, and to improve model interpretability by linking the structured common sense knowledge base with inherent knowledge obtained from language model. Thank you for your attention.